The focus of this chapter is the oxides of elements from sodium to chlorine. First, we will learn about the nature of bonding and composition of them. We can first classify the oxides as metal oxides and non-metal oxides. The first row shows the names and the formulae of the oxides. The second row shows the nature of bonding of these oxides. Ionic bond is formed between metal and non-metal elements. Hence, metal oxides like sodium oxide, magnesium oxide, and aluminum oxide are ionic oxides with ionic bonds between ions. Covalent bond is formed between nonmetal elements. Hence, nonmetal oxides like silicon dioxide, phosphorus pentoxide, sulfur dioxide, and dichlorin monoxide are covalent oxides with covalent bonds between atoms. The third row shows the nature of structure of these oxides. Metal oxides are ionic oxides with giant ionic structures. Non-metal oxides are covalent oxides. Among them, silicon dioxide has a giant covalent structure, while phosphorus pentoxide, sulfur dioxide, and dichlorin monoxide have simple molecular structures. The electron diagrams of the ionic oxides, sodium oxide, magnesium oxide, and aluminum oxide, are shown here. You should be able to draw these electron diagrams. Silicon dioxide is a covalent oxide with giant covalent structure. The structure of silicon dioxide is shown here. Silicon dioxide has a network of silicon and oxygen atoms held by strong silicon-oxygen single bond. Phosphorus pentoxide, sulfur dioxide, and dichlorin monoxide are covalent oxides with simple molecular structures. Their structures and electron diagrams are shown here. Phosphorus pentoxide is a large molecule compared to sulfur dioxide and dichlorin monoxide. It has 4 phosphorus atoms and 10 oxygen atoms in each molecule. Sulfur dioxide is a small V-shaped molecule with 2 sulfur-oxygen double bonds and a lone pair of electrons at the central sulfur atom. From the electron diagram, we can see that the central sulfur is non-octet as it has 10 outermost shell electrons. Dichlorin monoxide is also a V-shaped molecule with 2 chlorine-oxygen single bonds and 2 lone pairs of electrons at the central oxygen atom. From the electron diagram, all atoms obey the octet rule. Now, let's look at some physical properties of these oxides. Starting with the metal oxides, sodium oxide, magnesium oxide, and aluminum oxide, with giant ionic structures with strong ionic bonds between ions. They have high melting points and are solid at room temperature and pressure. Also, they can conduct electricity in molten state or in aqueous solution if soluble in water due to the presence of mobile ions. However, only sodium oxide is soluble as it contains sodium ions. Magnesium oxide is slightly soluble, while aluminum oxide is insoluble in water. Then, we move on to the nonmetal oxides. Silicon dioxide has giant covalent structure with strong covalent bonds between silicon and oxygen atoms. It has a very high melting point and is a solid at room temperature and pressure. It cannot conduct electricity as it does not contain any mobile ions or delocalized electrons. It is also insoluble in water. Phosphorus pentoxide, sulfur dioxide, and dichlorin monoxide has simple molecular structures with weak van der Waals force between molecules. Their melting point are relatively low compared with other oxides. At room temperature and pressure, phosphorus pentoxide is a solid, while sulfur dioxide and dichlorin monoxide are gases. This is because of the larger molecular size of phosphorus pentoxide. The van der Waals force between phosphorus pentoxide molecules is stronger than that between sulfur dioxide and dichlorin monoxide molecules. The melting point of phosphorus pentoxide is higher than sulfur dioxide and dichlorin monoxide. They also cannot conduct electricity as they do not have mobile ions or delocalized electrons, but are soluble in water as they can react with water. This will be covered in next video.